Four identical isosceles triangles are arranged as shown with points A, B, C, D lying on the same straight line. A new triangle is formed with sides the same length as AX, AY, and AZ. If AZ is equal to AE, the largest integer value of X, such that the area of this new triangle is less than 2004 is. The first thing I want to do is draw in these three lengths. So AX is from here to here, AY is from here to here, and AZ is from A, obviously, to Z, like that. And then I will draw right triangles. So I want to draw the bases, like that, all the way down. And these can be representing the base, or you can represent them as the height. It doesn't really matter. It just helps us figure out a lot of equations that we will need. Now I'm going to label them. The lines that I just drew, top to bottom, I will label those H, like that. And then these are right triangles, and therefore we can get Pythagorean relationships for each of these. So for AX squared, I get from here to here, which is 1.5x, so 3 over 2x squared, plus h squared. And then for AY, in a very similar way, I get from here to here, which is 2.5x, so that's 5 over 2x squared, plus h squared. And finally, AZ squared is all the way from there to there, which is 3.5x, 7 over 2x, plus h squared, like that. Okay? So that's the first part of the setup of this question. The next part is a clue that they give that's very important, very helpful, and that is AZ is equal to AE. Now AZ we've already calculated, but be careful. We calculated AZ squared, not AZ. So don't make that mistake, because you'll never get the right answer if you do. So AZ is equal to AE, and since I've got AZ squared, I'll just square both sides. It just makes it a little bit easier for me, like that. Now AZ we have right there, so I'll put that in here. 7 over 2x squared plus h squared. AE, what is AE? Well, it's all the way from A till E, and we know that's 4x, right? 4 of these guys. So that's very, very nice that it works out like that. So AE is 4x, and don't forget to square this. I think, the challenging part of this question, in my opinion, is these small algebraic errors that can be made. So now this helps me tremendously because I can isolate for h squared. I got 16x squared minus 49x squared over 2. And let's see what this gets. Oh, over 4. You see what I mean? I just said it, and then literally 10 seconds later, I made the same thing. So don't make those small algebraic mistakes, because you know how to do the question, but you make those small mistakes and you get the wrong answer, or you don't get an answer that makes any sense, and that's really painful. So you just add this fraction here, and you get 64x squared minus 49x squared over 4. And this is, let's see here, 15x squared over 4. And that is h squared. All right? And therefore, we can now plug that back into each of these and get a value for each of those in terms of x only. So let's start with ax squared. Ax all squared, therefore, will be 3 over 2x all squared plus h squared, which is 15x squared over 4. And this looks like 9x squared over 4 plus 15x squared over 4. And this is 24x squared over 4, which is 6x squared. And that's ax all squared, so therefore ax is root 6x. Correct? All right, let's do the same thing for ay this time. Ay all squared is 5 over 2x all squared, so that's 25x squared over 4, plus h squared, which is 15x squared over 4. This looks like 25 plus 15 is 40. 40x squared over 4, and that is 10x squared. And therefore ay, we have to take the square root, don't forget that, root 10x. So we got ay, we got ax. Now we need az, but az is equal to ae, so we don't need to do this algebra. Az is just ae, and ae is 4x. So az is 4x. And there you go. There you've got the three sides. Now at this point, you think, well, okay, I've got three sides of a triangle. How do I figure out the area? I mean, do I use herons? Some of you may not even be familiar with herons. And herons is a really cool, where if you got three sides of a triangle, and those sides are, say, A, B, C, and you don't know any of the angles, you can still figure out the area. First thing that you do is you find the perimeter, which is of course A plus B plus C, and then the area is the perimeter over 2 times the perimeter over 2 minus A times the perimeter over 2 minus B times the perimeter over 2 minus C, like that, all under the square root sign. And this will give you the correct answer. But as I'm staring at this, I got a little bit of a inspiration that I think these form a right triangle, which is very nice of them to do that. I believe so, because if you do ax squared plus ay squared, I think it equals az squared. Let's see here. Ax squared would be 6x squared, ay is 10x squared, and az is 16x squared. Yeah, it does. There you go. So this is a right triangle. Very nice. So that means you don't need herons. Well, doesn't break my heart, that's for sure. All right, so that means that this is a right triangle. And let's just label this. So this is a right angle right here. And this has got to be AZ. And this is AX. And this is AY. So this is what? Root 6x, root 10x, and 4x. Okay. All right. We got it. So we can figure out the area using just the standard 1/2 base times height. 1/2 base, so root 10x times height, which is root 6x. Okay, great. So what does that give me? Root 60 over 2x squared. And let's just go back to the question, remind ourselves what it is that they want. The largest integer value of x such that the area of this new triangle is less than 2004. Okay. So they want this area, root 60 over 2x squared, to be less than 2004, and they want you to solve for x. But they want an integer value for x. Okay, no problem. So that means x squared 2004 times 2 all over root 60, correct? And then let's just get the numerical value of this. And this is 517.4. And therefore, if I take the square root, it'll be 22.74. And they want the largest value of x to make this true. That is an integer. Well, that would be x equal to 22. Correct? So let's see here. The largest integer value of x such that the area of this new triangle is less than 2004. Yeah, 24, the answer is E. Excellent question.